The checks, that's the human checks and efficient outcomes with visual efficient.
Hello. Hello.
Hi.
Hi.
I sent you an email last Tuesday, I think, about your office hours. Because
And I haven't replied.
No, I haven't replied.
Are you sure?
Yeah, I checked it.
Can you double? Have you checked it today?
Yeah.
Okay, so can you send me again because I thought that I replied to everyone.
Okay. Yeah.
Can you please? I'm sorry about that. I have like crazy number of emails. I thought I replied to everyone, but if not, can you send me again and I will.
Yeah. I
So
will
that's to schedule like a different time for office hours or
sorry?
what was the email about?
Yeah, it was about you being my academic mentor, and there was no time slots available, on which I was available as well. There was, I think, 2 left tomorrow, but then I have lecture.
Okay, so few email me about the same thing, and I kind of schedule like other office hours time. So if you can, I'm sorry about that. If you can re-email me, and we will sort it out. Okay. Thank you. Sorry again. All right, let's make a start. Let me remind you what we did last week, and I'm gonna tell you what we're gonna do today. Hopefully, if time permits. Just wait for a few more seconds so everyone settle. All right. So last week we covered, kind of discussed what are public goods, public bads. Talked about externality, but I think most importantly, we explore how the assignment of property rights could, at least in theory, solve the problem of market failure when we talked about the cause theorem. And if you remember, we saw that the assignment of property right, that with assignment of property right, we will get efficiency independent of who we give the property rights to. Having said that, we showed specifically in the seminars that it's not that it doesn't matter for everything, it matters a lot for distribution. So it matters a lot who gets more profit, etc. So obviously, the entity has an incentive to have their own property right. But the same, but the main point was that assignment of property right does solve the issue again, at least theoretically, and we get efficiency. So that was great. Today we will explore another and I guess more realistic approach to solve the market failure. We're going to talk about taxation, about environmental taxes. That's going to be the main topic of today. Basically, the government will tax polluter, and then give a price to pollution, another way to think about it. And then we will check whether this proposition of introducing taxes reach efficiency. And remember our definition for efficiency. We're going to want to get to the desired level of pollution that we will determine first. And also importantly, we want to make sure that we get to this desired level at the least cost way. So we're going to talk a lot about that. We're also going to talk about other stuff related to taxation. Some of the other things that I'm going to mention are very positive. You might, in some point, going to find me too enthusiastic about taxes, all right, and how great they are. But I'm also going to discuss something that you probably don't want to do, or something that you need to be worried about. Actually, that's a better way to explain that. That you really need to think very carefully about how you design a tax, okay? Because otherwise it can backfire. So what you want to think, and obviously I cannot show you everything that you need to think about, but I just kind of show you an example, or one or two things that kind of I think true across the board. But because maybe in a year from now, some of you are going to think about how you propose new taxation to policymakers. Oh, indeed, you're going to decide on some taxes. So I want you to really kind of think about this stuff. And at the end of the day, remember that people actually have to pay these taxes, and that can have significant impacts on their life. All right. So I love taxes, but you also need to remember where we operate. Okay, because this is real stuff. So we need to be mindful of that. Then towards the end of this lecture, we're also going to talk about subsidies and check whether subsidy, which essentially is a negative tax, give us the same results as taxation, and why we even care about subsidies if taxation is so amazing. So we're going to talk about all of that, and then really at the end, maybe 5 minutes or so, maybe 10 if I'm super generous, we're going to talk about command and control because I don't like it. Okay? And I tell you why I don't like it. Okay? Not for everything, but for most things. Okay, now obviously I'm super biased because I'm an economist, but you're also an economist, so you're also biased like me, which is great. I'm joking. I'm going to show you actually why this is the case, why command and control in most cases doesn't make sense. All right, so let's kind of start. Any questions before I start, by the way? No. Problem set is live from like last week in response to your comments, so it's always going to be the week before. I also added on Moodle for last week like 2 textbooks if you want to kind of refresh your memory about micro and about math. So 2 books that I recommend. So if you want to go back to the week 2 to the Moodle page, and you see it at the top. Again, any question that you have, feel free to email me. I tried to answer all the emails. I thought that I did. Apparently, I did not. So if you haven't received a reply to me and you send me an email before today, please email me again, okay? I'll just get a lot of emails. I'm teaching not just you, I'm teaching other course, which is a very big course for undergraduate students. So I get a lot of emails in the last 2 weeks. But I am trying, and I have emails from other people. But you are my priority. So email me again, and I'm sorry if I haven't responded to any of you, okay? I'm doing my best. All right, let's talk about taxation, which is beautiful. All right, so first proposed environmental taxes by R2 Pigo, long time ago, and still one of the most commonly advocated instruments by economists to address environmental externality, the market failure that we have in mind when we kind of think about what we want to do. It's something that I think is increasingly used, definitely since the 1980s and into the 1990s, and much more in the 2000s. Especially in areas like waste management, air and water pollution, and other environmental issues. There are two types, I guess, of taxes, broadly speaking. One is emission taxes, so this is when we levy the pollutant itself. For example, tax on SO2, which is a type of pollutant, something like that, specifically on the pollutant. For every unit of emission that you, as a firm or as a consumer, emit to the air, we tax you on that, right? That's one way to do things. The other way is what we call the product charge. So then we don't tax the exact emission, we tax the product, the final product that actually lead to the pollution. So you can think about taxes on fuel, for example, right? So it's not that we tax the emission coming out of your car, we tax the fuel that the fuel in turn create the pollution, right? Now, the point about, and this is kind of how we think about taxation here, is that we're going to allow entities in our economy to pollute as much as they want, as long as they pay us a fixed price per unit of emission or output. Okay, let's think about it in terms of per unit of emission. It's just going to be easier to understand how it works. That's it. So we're just going to set a price, set a tax, and we're going to tell everyone you can do whatever you want as long as you pay us the tax. And I'm going to show you how that very simple thing works so beautifully. Okay? And it's very hard for people outside of our profession to grasp that. They need to be aware of that. Because basically what I'm saying, that firms can do whatever the hell they want as long as they have the money to do that. So it's not easy to other people to agree with this proposition. But I'm going to show you why it makes a lot of sense. And I'm trying to show it to other people as much as I can. Okay? But let's see how it goes. All right? So let's take a very, very, by the way, when we tax it, what's going to happen? We essentially going to deal with a problem that we have with the pricing system. That's not going to capture some of the externality that we mentioned last week. Right? So we're going to correct the the price system with a tax. So we're going to internalize the externalities, and then it's going to work through the price system by using the tax. Okay? This is how it's going to work. But let me kind of show you that very, very slowly. We're going to look at math, we're going to do some diagrams, we're going to talk, it's going to be fun. All right, let's do that. So let's kind of think about something very, very simple. Consider a firm that produces output Y and pollution X. Pollution reduces its cost, so they don't need to think about abatement. It's another way to think about it. We can ignore Y for now. It's just going to make our life easier. It's not always the case, but in this case, it's going to make our life easier. And we have a cost function, which is given by Cx. Let's further assume that there are n people that live near the factory that produces output Y and pollution X. And pollution causes damage. That's the point, right? There is an externality here. Okay, so the damage for each individual for the n people that live near the factory is given by this damage function here, di. Okay, so it's the damage function for individual I, which depends on x, and that's a positive. So basically, the damage is positive, it means it's a negative externality. Right? So the more x that being generated, the more pollution being generated, the greater the damage is. Another way to think about it, what is this di, is the willingness to pay to clean the air or something like that, or not to have pollution. Okay? This is another way to think Okay, so the willingness to pay to eliminate pollution. The reason why I'm saying that is because later on in the term, we're going to think about estimation. We're going to try to think about how we actually estimate the marginal damage. So I want you to think about it already in this kind of, way. Okay. All right. So now we can aggregate all the individual damage function, all the DI. So we're just going. This is just summarizing, right? So we're going to sum all the DIs, right? All the individual damage function into an economy-wide damage function, which is this guy here. This guy here is just summation notation, right? Okay. So what is the efficient level of pollution? Look at you. Week 3 into your MSc, we're gonna find out what is the efficient level of pollution. So you can think about what's the efficient level of pollution in London or whatever. This is the same way that we're gonna do it. Doesn't matter. Obviously, in order to do it properly, you're gonna need some, some actual numbers and some actual marginal damage and things that I'm gonna show you today, which we're going to do again later in the term, but the concept, you will understand it today, right? How we can do that, how we can find out what's the efficient level of pollution. I told you that one way, we need this benchmark, right, in order to know where we're trying to get. How do we do that? We kind of did it last week, in fact, right? We said we can just merge the entities together. Remember that? So we're going to do that. We're going to merge the entities together. In this case, the entity is going to be the firm that produce output and the people that live next to the firm. Okay? So these are the entities. So when we're going to do that, what's going to happen? Well, we're going to try to minimize the cost for the firm, right? So firms, yes, they want to maximize profit. Another way to think about it, they're trying to minimize their cost, right? And the residents, what do they want to minimize? They want to minimize the damages, right? So, last week I think we talked more about maximization. Today we're going to kind of change and we're going to, and we're going to talk about minimization. All right, so we're going to try to minimize all of that together just to get a benchmark to what we're trying to achieve. Okay, again, you don't have to do that, but this is what we're going to try to do. Yes?
Just said we ignore the revenue. Does it mean sort of keep it fixed in our mind for now, or like the output?
Yes. Yes.
Can we solve this like, for example, the typical profit maximization, but internalizing the T as the cost?
So as I said in the seminars, there is lots of these things. You can solve it in different ways. I'm just using the thing that I think is the easier to understand and to make some points. But totally, you can solve things in different ways. That's true both here in lectures and also in the seminar. If you, again, as I said, I don't know if you were in the specific seminar, but if you have other ideas and you're not sure if you do it right, you can feel free to email me and I can go through it and make sure that it's correct. Okay, so let's minimize this thing. This is exactly what we just said, just mathematically. We're going to try to minimize, right, this cost of the firm plus the damages. So this is the merge entity that we just created, okay? And we just take the first order condition for that, right, equalized to 0. So we differentiate that with respect to x. What do we get? We get this expression here plus this expression here. What is that? This expression here, which I basically just move it here, sorry, I can just rearrange it here, but even I can rearrange this guy here, but before I even do that, what is that? This is the marginal cost, right? And this guy here, what is that? The marginal damage, right? So we said the marginal cost plus the marginal damage equal to 0. This is what we get. We can rearrange that such that we get that the negative of the marginal cost equal to the marginal damage. Okay? The economy-wide. This is what we want to get. Yes?
Why are you setting the marginal damage equal to the sum?
Well, this is the same thing. It's just the sum of all the individual damage function. It's equal to the economy-wide damage function,
Okay. So
which we define here.
it's the sum of the marginal damages.
Well, it's in this case it's the sum of all the marginal damage. Yeah. Okay, so this is what we get. So again, this is just the negative of the marginal cost. In the Costa textbook, Charles Costa called it the marginal saving. Yeah. Well, well, in this case, it's how the costs change when we emit another unit of X, but it's actually about Y. I just kind of try to make it simpler, right? But it's the change of the cost with respect to, let's go here, with respect to X, which is actually the pollution. Another way to think about it, that's what I said before, you can think about it in terms of like, if I don't, and this is why it's easier to think about it sometimes from marginal saving and marginal abatement costs, that if I emit, I don't abate, because abating is a cost. That makes sense. So this is, it's negative, which is basically mean it's lower. But if you're going to move it to marginal saving, this is what I'm going to say now. So let's see if that maybe clarified. So basically, what Charles Colston is saying is that it's just with all marginal costs, it's a bit kind of less clear. Okay, so what we need to think about, we need to think about it in terms of savings. So if we emit, we do not need to invest in abating. Okay. The way that I think about it is I just call it marginal abatement cost, which is all kind of very, very similar things. So I'm going to use a lot of marginal abatement costs. I'm just thinking about it as an abatement, how much it costs to abate. Okay. So our goal here is to achieve this level of pollution where marginal saving to firms are equal to the marginal damage to the population. So this is kind of the first thing that we want to achieve. All right. And we already seen that market is unlikely to achieve that if we don't do anything. What we're going to try to think about is to impose a tax, and we're going to try to think about what's the right level of tax, such that we will reach this this level of pollution, this condition that we just showed, and the payment here that we're going to impose here going to go to the government. Okay, we're going to get the efficient level of pollution. And by the way, if we set the price, the tax rather, at the right level, this is when we call it Pigovian fee. Otherwise, we can just call it environmental tax. But the Pigovian fee has to be the tax rate at the efficient level of pollution. So that's a distinction between these two things. Okay? So a Pigovian fee is only when we set up the tax at the efficient level of pollution. Right? All right, so let's kind of do the formal definition, and then I'm going to go through this figure for a bit. A Pigovian fee is a fee paid by the polluter, parent of pollution, equal to the aggregate marginal damage caused by the pollution when evaluated at the efficient level of pollution. Again, that's the point I made today. The fee is generally paid to the government. All right, so let's kind of go through this figure and see what's going on. So here I have the price of emission on this axis, and here I have emissions. And what do we have here? Let's start with the marginal damages. So the marginal damages are for, let's say that we have two, individuals or whatever entities in this economy, and we have marginal damage one, marginal damage one, marginal damage two. We can aggregate them into the aggregate economy-wide marginal damage function, which is this guy here. And here, this is basically this line here. This is the marginal abatement cost, what I mentioned before. Okay. And obviously, it's, well, I mean, the shapes of it and the way that it looks, this is an empirical question, by the way. And we're going to do a lot of that in the second or towards the end of this term. This is basically my research. But yeah, so it doesn't have to be a straight line, doesn't have to look like that, but we're just going to assume that it looks like that. The point here is that what we basically implicitly assume when I draw it like that is that the damages increase with emission. Okay, so at the lower level, the emission has impact, but it's not as much as when emission and therefore pollution goes up, so the damages become higher. Again, it really doesn't have to look like that, but it's just going to make our life easier. It doesn't really change what I'm trying to show you. In terms of marginal abatement cost, why it's downward sloping here? Again, we're gonna think about it. It's quite hard actually to estimate that stuff. But you just need to think about it in terms of like marginal abatement cost in terms of abatement. So think about, because abatement is the opposite of emission. So it's going to be an upward sloping in an abatement space. What do I mean by that? So the point is that it's relatively cheap to abate a bit. It's very expensive to abate all. Right? So it's relatively cheap to abate a bit, but then it becomes very expensive to go all the way to zero. Why? Because, for example, if you're a factory, you might be able just to shift things around a bit in order to reduce pollution by tiny bits, shift labor, to do something small, change a bit of the input. If you really want to take it seriously, go all the way down to zero, that becomes very expensive. Right? This is kind of more from engineering, but actually, as an economist, we also, and there are a few good papers actually trying to estimate the marginal abatement cost, given some really cool data set and some natural experiments. Okay. All right, so given that we have that, let's kind of try to think about what's the efficient level of pollution and what should be the tax rate. Well, the efficient level of pollution, I would say it's here. At this point here, X star. By the way, I still use emission and pollution interchangeably in like week 5 or 6 or 7. I don't remember which week. We're going to relax this assumption, okay, because it's not exactly the same thing. Okay, we're going to talk about space. We're going to see why emission and pollution are not the same thing. Anyway, okay, so why is that here? Because let's think about it. If we here, for example, at this point in here, the marginal abatement costs are actually greater than the damage that's being created, so producing an additional unit of X to abate it is more expensive than the damages, then why would we want to be here? If I'm in this side of this picture here, then it looks like the abatement is lower than the damages, then it's worth for me to go down this direction, right? So basically abating more. So we're going to end up exactly in this point in here, because in this point in here, damages are higher than abatement costs, so it's definitely worth abating. And this point in here, it's not worth abating. We're going to end up here, right? So that's going to be our target. And my point is that this P star, that should be where we should introduce the tax. Okay, so that should be the level of tax. So in theory, if you have the actual marginal abatement cost curve, which is something that you can estimate empirically, and if you have the marginal damage, at least the economy-wide marginal damage, you can already set up a tax. And that's it. So the only thing you need to do is say P star equal T and forget about it. And that's going to solve all your problems in life. Well, not all your problems in life. It's going to get you to the efficient level of pollution. Okay? Okay. Any questions about what I've showed you so far? No? Okay. Before I kind of talk more about tax and show you how how it's achieve efficiency, I just want to show you and kind of walk you through one more thing. Why? Because sometimes I've been asked whether it's kind of makes sense to not to give the money to the government in a way, to basically give the money to the government, then compensate the victims of the pollution. And the answer is that this is something that you probably don't want to do. And there are two kind of options here. One is that if you actually give the compensation to the victims, right? But this doesn't really have any impact on the behavior, then it's just a welfare or an income transfer rather. Okay, so it doesn't really serve anything in terms of the actual environmental regulation. But I think more importantly is the second chance, which I think is more realistic. If you actually change people's behavior, that might be a very bad idea to do that. Basically what you're going to do, and we talked about it last week as well, you're going to provide people incentive to move towards pollution, and you're going to distort the market equilibrium, right? So basically, as I mentioned last time, I think it was an example with the airport. I think it's noise and airport, that's what I use, right? So you're basically going to give incentive to people to move towards the airport because they're going to get obviously some compensation for that. But that's going to distort the optimal allocation of residents across space. Yes. And we assume that they don't actually reduce the noise while this is happening.
But if the pavement, yeah, in the case that it doesn't change the
Not for everyone. It's for the victims. Not for everyone. We're going to talk about what you do with the revenue later today. But this is specifically for the victims, right? So again, if they react to that, then that's a bad idea. If they don't react to that, I don't really necessarily see the point. But you can think about other ways to transfer income for other taxes.
If they don't react, then at least it has distribution of benefits because they probably.
What's the distribution of? That's a great conversation. Let's talk about it. What's the distribution of benefits?
Because if they're suffering the pollution, they're probably worse off than others. So it's better than.
Are they? I don't know. They made a decision. I made a decision. Every one of you had a decision on where to live. When I make this decision, I take lots of things into consideration. I make these trade-offs. I made this trade-off. No one forced me. At least in this country. But I say I decided to live, in less polluted area, but I decided to live in a smaller house. For example, well, I don't live in a house. I live in a flat. But you know what I mean. Why do I need to, someone else could have done exactly the same thing. Why do I need, for example, compensate someone else right now? I'm just asking. Or why do not I deserve some of this income? I could have lived there, but I decided not to. I'm not saying that I'm right or you're right. I just want to know why. And if you want to solve distributional issue in society more broadly, why do you necessarily need to use this taxation?
Sorry, I'll jump into that. What happens if the individuals aren't actually taking away for completely without the cost of living?
Right, this is a different issue. This is a different of information. I'm completely in favor of, providing. I have lots of work on that. Provide more information. But what I found in many cases, certainly in pollution, that even when you find information, even if you provide this information, you find it interesting how people react to that. Because look, we obviously, you came here and you study environmental economics, so I suspect that you care somewhat about the environment. But some people just don't, which is fine, even if they present it with their information. At the end of the day, it's their decision. Okay? But this is another issue. We're going to talk about that as well, to provide information. But I'm telling you that in many cases, even when you provide information, that doesn't change. Because people, it's not that they don't care necessarily about the environment, they just care about other things more, I guess. Which is, some people are more sensitive to certain things, and some people don't. Some people have different kind of risk tolerance. Some people have different attitudes towards risk, which is similar, but not exactly the same thing. Yes?
And perhaps not necessarily to use like the revenue to compensate the victims, but I think it's probably important to use the revenue to as a more broader policy to reduce improve equality in society, right?
Well, so first of all, here we're just talking about, I love these conversations, by the way. So here we're just talking about compensating the victims, right? One. About reducing inequality in society, is what you mean? That's a different objective. This is not for my course. So, I'm not saying that I'm not in favor of that, but this is not what we're trying to solve here.
Yeah, but I think it's related because of the way we are measuring the damage, because we're measuring damage as willingness to pay. So what happens if the factory is near a very poor neighborhood or something, and so these people have their willingness to pay to get rid of the pollution is very low because they have low income. So it's important if we want to weigh.
No. We're going to talk about how you actually estimate it. We're going to talk about the estimation about and the welfare consequence of that. I'm going to show you that specifically in the case of pollution on week 11. We're actually going to do that. So I'm going to talk about, and yeah, there is definitely an issue here. I'm just being a bit provocative. We're definitely going to talk about distributional aspect. I'm just trying to push you a bit. I hope it wasn't too much. But I'm just trying to say that we need to think about what we're focusing here on. And there is a whole slide about what we do with the revenue. So let me kind of come back to that a bit later, all right? But that's kind of my main point, is specifically about the victims. You probably don't want to compensate them for that, as horrible as it might sound. All right, so let's talk about about the tax a bit more and talk about what we call the static efficiency. What do I mean by static efficiency? It means that I want to get the efficient level of pollution, okay, at the least cost way. This is what we call static efficiency. I'm going to differentiate that to dynamic efficiency, which I'm going to discuss in a few slides. All right, let's see where we are in terms of time. Perfect. All right. So what do we have here? We have the marginal cost, marginal benefit here. We have the quantity of emission, and we have two polluters here, okay? We have marginal abatement cost 1 and marginal abatement cost 2, which is the two different firms, I guess, that pollute the air. Why do we have different marginal abatement costs to two firms? Can be many reasons. Can be different management practice, different technology, all new firms, you name it, right? So they just have different costs in order for them to reduce their pollution, okay? And we have the marginal damage cost, and then we also have the economy-wide marginal abatement cost, which is just this guy here, okay? All of that here. Just gonna do horizontal summation, and we create the marginal abatement cost, the economy-wide marginal abatement cost, okay? All right, so let's think about what we want to do. So we know that in the absence of any intervention, right, these two firms, let's say, they want to invest zero in abatement. Okay, they don't want to spend money if they don't have to. It's not because they are bad, well, maybe they are, but it's just because they're trying to maximize their own profit. So in the absence of any intervention, we're going to end up in what we call E-private, which is basically both firms emit as much as they needed in order to maximize their own profit. Now, the second thing that we want to find out is what is the efficient level of pollution, right? And what tax we need to get. How we need to set it up. So in this case in here, and as I mentioned before, it's just going to be the point in which the aggregate marginal abatement cost equal to the marginal damage. So it's going to be at this point in here. So that's going to be the efficient level of pollution. So, and that's going to be the tax. And we're just going to have to, so basically our target here is to move from E-private to E-efficient, right? That's the target here. So let's see how that actually works in terms of the individual firm, how they form their decision in response to the tax. And then I'm going to show you how that essentially going to lead to moving from E-private to efficient. And then I'm going to show you here on the diagram why this is cost effective as well, right? And why can we discover the static efficiency. Then we're going to show it mathematically. But let's do it on the figure, okay, first. So we have two firms here. We set up the tax like that, right? At T star. Now each firm can make a decision. Don't forget what we said with Pigovian fees, right? We set at the right level, so that's going to be a Pigovian fee, right? When MDC equal marginal abatement cost, that's great. And then the firms can do whatever they want as long as they pay us the tax. Remember that? Great. So let's see what they're going to do. Firm 2, right? They have marginal abatement cost 2. They need to make a decision whether they want to pay a tax or abate. They start here, right? This is their E-private, this point here. Can you see that? What is cheaper for them, let's say here? Is it cheaper for them to abate or pay the tax? Abate, right? It's cheaper for them to abate because the tax level is here, it's T star. This is cheaper. So it's cheaper, all the way up to here. This point here, it's already more expensive for them to abate rather than pay the tax, so they might as well pay the tax. So they're going to move from here to here. Okay? Does that make sense? You know what? Let's do it differently. Hold on. Maybe it's going to make more sense. Hopefully it's going to work out. Okay, so basically they started here. Of course that doesn't work. They started here, and they're going to move to here. And what's going to be their marginal abatement cost? It's going to be this guy here. You can't see anything. Oh, I can only see it here. That's annoying. All right, sorry about that. So let's go back here. I guess it doesn't work. Now my computer doesn't work either. Now it works. Okay. I'm not going to have to jump around. Sorry about that. But basically, what's going to happen, they're going to pay this triangle, right? This triangle here, this gray triangle, as their abatement cost. Is that all they're going to have to pay, by the way? Or they need to pay more? Exactly, right? So they're also going to have to pay the tax, right? This is the level of tax, times the distance from here to here, right? So essentially, this is why we say with taxation, polluters pay twice. They're going to hate that. They don't want to pay. They rather be at e-private. What I just did here when I introduced this tax, they're going to pay me one in terms of abatement cost, which is this amount here. The second amount they're going to have to pay is this all of this area here, which is the tax rate time the amount of emission they actually emit. Because they didn't go all the way to zero, right? They now move from here to here, and they need to pay per unit of emission. Right? This is firm 2. Let's look at, and they, again, for them, of course, they prefer no taxes. Of course. Right? Because they need to pay quite a lot. But if there are taxes, this is what they're going to do. This is how much they're going to abate. They're going to move from here to here. Let's look at firm 1. The marginal abatement cost is equal 1. They have a much better marginal abatement cost. Right? They have better technology. It's cheaper for them to abate. What happened with them? Again, the tax is equal for everyone. T star. That's what they do. Right? That's what we do here. It's very, very simple. We are lazy. We don't want to do too much. I'm joking. It's actually important to get everything that we want. What they're going to do? They're going to do they're going to make the same decision. Do I want to abate or do I want to pay a tax? So here it's cheaper for me to abate, cheaper to abate, cheaper to abate, still cheaper to abate, too expensive, better to pay the tax. I'm going to end up here. All right? At this point in here, what's going to be my abatement cost? It's a much larger area, right? So basically what I'm saying that so firm 1 with MAC1 going to do much more abating. They have much better technology. It's cheaper for them to abate. They're going to do most of the abating. Is that fair, by the way? What do you guys think?
Yeah.
Why?
Because the firm is investing in innovation. For that, they are trying to make technological progress for them to actually recognize more.
But what I'm saying is that actually we introduced a tax, and now they have a much larger abatement cost. That's what I'm saying. And I'm asking whether this is fair or not. So yes.
But their marginal cost is the same.
What do you mean?
The marginal abating cost remains the same.
Yeah, but they could just going to do much more abatement. Does it make sense from an overall perspective? So you raised your hand before? Yes. I'm just trying to let other people. Yeah, go ahead. Let's say all the tax go to the government, and then we just throw all the tax into the river of another country. If you don't want it. Yeah. Maybe fair is not the right word. So maybe does that still make sense that they do most of the abatement for them, for their own sake? Yes.
Yeah, overall, if we want to make the abatement as cheap as possible, we have to ask the ones with the cheapest to do more.
Yeah, I want that, but do we basically penalize them for doing that? For being like so amazing? Yes?
So the polluter that pays greater tax abates less. So, like, anyways, if they are putting more efforts to abate it, they have to pay lesser tax.
Exactly. That's the point. I know that I'm just trying to let other people participate. That's what I'm trying to do. That's the point. That's exactly the case, right? Because basically, you need to think about the total. First of all, it's individual decision. If it wasn't in their best interest, they wouldn't do that. They can do it. Remember, they can do whatever they want, right? But what they're trying to minimize here is the amount of two things. One is the abatement cost, for sure. but also the amount of tax revenue that they pay. So who pays more in total? Obviously, firm one. Why? Because the total amount that they pay is this, yes, bigger triangle here, for sure, but then the tax revenue is just this guy here, right? It's the tax, right? Here, T star, time this distance. For the other firm, for marginal abatement cost 2 firm, so firm 2, their marginal abatement cost, right? So how much they pay in terms of abatement is lower, totally true, but they need to pay all of that in terms of tax. So overall, firm 1 pay this amount less than firm 2. So they totally pay less. So it makes sense that, and it kind of, obviously they wouldn't do it if it didn't make sense to them economically, but it's also kind of, provides some incentive. We're going to talk about dynamic because I think you were talking about innovation. We're going to talk about it in like a few slides. But basically, the point here is that they're not going to pay more. The other thing, before I take your question, is that what we want? This kind of going back to your point. This is exactly what we want to reach efficiency. Because basically what I want is that the entity that it's cheaper for them to abate, to do most of the abatement. Because that means that we reach e-efficiency at the least cost. All right? So this is what it says. Another way to think about it, you can merge these two entities together, assume these two firms are together, and you ask them, look, what's the best way for you to reduce the emission from e-private to e-efficient? Let's say that you have two plants, and they would probably come up with the same solution. Okay? And what we get here is that we get that at this point in here, right, the marginal abatement cost for all firm is equal to each other. And that's kind of the condition that for efficiency. All right, that we wanted, which is great. And it's just by setting up to t equals star. Sorry, you had a question.
Yes, it might be obvious, but doesn't it sort of mean that if there's a risk of a tax coming, that we create an incentive for firms to innovate?
We're going to talk about innovation in just, in a few slides, and we're going to talk about because what I'm saying here, this is static, so we don't think about time dimension, we just think about at one point in time. We're going to introduce time in I think, a few slides.
Okay, if we cut out the innovation, but bottom line, this means that essentially the firm with the lower abatement cost now has a competitive advantage over the one with the higher abatement cost if they were satisfied with otherwise.
In a way, yeah, it's going to be cheaper for them. They're going to pay less, yeah. By the way, no one won the tax. Not no one. None of these firms will want the tax because they pay quite a lot. They rather have no tax, okay? But maybe, I think going to your point, maybe if this is a given, maybe some firm will gain from it more than others in terms of competitiveness. Yes?
It's just because the no firm wants that. If we mention two extreme cases, two steel companies, one super green hydrogen and the other one super bad.
Yeah.
Couldn't it be that the super green firm then wants the abatement cost, or like wants a CO2 tax, because then it would give them such a tremendous
Could be.
competitive advantage that they actually want it.
Could be, but that's going to be quite an extreme. And it also depends on the tax level. But I can see a scenario that can work. Yeah, that's a good point. Okay, so this is kind of what I wanted to show on this one. Let me see if there is anything else that I want to say that is important. No, I think that's it. Okay. So basically, what I just showed you in a figure is that with taxes, without doing much, just to get some understanding of the marginal abatement cost, the economy-wide marginal abatement cost, and marginal damage, we can set it up in such a way that we're going to move from e-private to e-efficient, because basically the sum of this reduction in emission will basically going to be the distance from e-private to e-efficient. So we got what we want, we got an effective policy, but we also did it in the cheapest way possible. The cheapest way possible means that we allocate the abatement effort in such a way that we basically do it in the cheapest way. So firm one will do most of the abatement and firm two will be less than that. But the condition for cost minimization, as I'll show you mathematically in just a slide or two, is that at the end of the day, the marginal abatement costs across all firms at this point going to be equal to each other. Okay? So why is that? Because we just take as much as we can from, remember that I told you in the beginning it's very cheap to abate and then become more expensive? So we take it, the kind of the beginning bits from each firm as much as we can. Okay? By the end of the day, we're going to reach this kind of cost minimization requirement that the marginal abatement cost is going to be equal across all firms. Okay? And I think that's pretty much what I wanted to say about this. Let's see if there is anything else. In controlling emission from several polluters, those emissions all contribute to damage in the same way. We call it the equal marginal principles, require that marginal cost of control be equated across polluters to achieve an emission reduction at the lowest possible cost. Clearly, a pollution fee satisfies this principle because, again, it's going to work through the price, it's going to work through the tax, right? Each firm, they don't need to talk to each other, they don't need to do anything. They just basically decide, it's cheaper for me to abate or pay the tax, and they're all going to equate, essentially, the marginal abatement cost to T. And that guarantee, because T is the same for everyone, that the marginal abatement cost is equal to everyone. That's the point. Okay? All right, so we're going to do that, and then we're going to take a break. So let's do it mathematically. Basically what I show you with the diagram just now. So let's think about n polluting firms. Each firm is I from 1 to n. Firms I output and pollution level is given by QI and EI. Unconstrained maximum profit and emission level is given by this profit and pi hat and E hat. Cost of pollution reduction is given by this const function, which depends on pollution level, with EI is less or equal to the unconstrained level of emission. And we can use this cost function just to make our life slightly easier, or just as an example, we can use this specific cost function. We can change it, just it's going to be easier to work with. And what we can do, we can decide what is E star. Essentially, we want to think about what is E star. This is the desired level of pollution. Okay, you already know how to do that. It's the marginal damage equal to the marginal abatement cost. Okay. So we're trying to think about what is the most efficient way of achieving E star, right? And we can just basically set where we want to get. So again, move from E private to E efficient. So let's think about that. All right. So how to do that? We can set the problem in the following way, okay? We're going to try to minimize the cost subject to the following constraint, that E star are going to be equal to the all the emission that we have from the different I's in our economy, okay? So it's the sum of all the different emissions, okay? And you already know how to solve constraint optimization problem. In this case, last week, I think we did a maximization problem. Today, we're going to do minimization, as I did before. You can set up as a Lagrangian, right? So first thing first, this is the objective function. So I put it here, and then I can set up the constraint here. Again, this is just to ensure that we get the desired level of pollution. So if everything works right, you kind of guarantee that you're going to get E star, which is exactly what we want. So this is what I did here. This is the Lagrangian. You can rearrange that a bit, and you already have the cost function. This is from the previous page. This is the cost function, so I just replaced that with this guy here and kind of rearrange that a bit. No, this is actually stay the same. And then you can just solve that, right? So you take the first order condition here, so it's equal to 0, so you differentiate with respect to EI and with respect to lambda. So what do we get here? We're going to get, essentially the what we want, right? So this is kind of by definition. So if we move that to the other side, you get the constraint, so you get the desired level of pollution. But what is that? I mean, this is just the, when you differentiate with respect to E1, and what you're going to get this marginal cost, right? You can move it to the other side, you're going to get the marginal saving, which equal to this lambda. Now, lambda is equal across everyone. Basically, what it says that for cost minimization, you want that the marginal saving or marginal abatement cost is going to be equal, in this case, lambda. It doesn't matter. It's just equal across everyone because lambda doesn't have a subscript. doesn't vary. So basically what I just showed you is that it's exactly this point in here that to get cost minimization, you want to be in a situation that all the marginal abatement costs across all firms going to be identical, going to equal to some constant, which in this case in here was this, where was that? Lambda, or whatever that was. This guy here, right, if you move it to the, oh, this is the marginal cost, so you move it to the outside, it's the marginal saving. But that can be equal to, if you set that equal to the tax, that's exactly what you're going to get. Right, so that's the kind of the math version of what I showed you in terms of cost minimization of the diagram before. Right, so this is kind of the condition for cost efficiency. So this is why we say this is efficient, right? So we get the desired level of pollution. This is kind of this guy here. And we did it in the cheapest way possible when we get the tax equal to this guy here. Okay, because everyone going to equate, okay, all firm will equate their marginal abatement cost to the tax. That's the point. And this is the equal marginal principle that we mentioned before. All right? Let's take like a 10-minute break to kind of, relax. Or slightly less. Let's come back at 5 past 5, okay? If there is no tax, if we don't do anything, yeah, they don't have it. The point is that if you can manufacture, I mean, if you just care about your, if it doesn't affect, so it's assumed that it doesn't affect your emissions. But then why would you do it? Oh yeah, I'm going to show this. Yeah. So again, there is more. So I prefer to think about this marginal abatement, but it's just the negative of that. But the way that I think about this, like, it just again, I think the book that probably do a better job explaining things. But the way that I think about it is, what's the cost of abating? Okay, so this is how the way that I think about it. So if you abate a bit, it's not as expensive, but once you try to abate a lot, so going to zero, then it becomes expensive. Right? Or another way to think about it, so the marginal cost, because think about the marginal cost of emission, it's a bit funny because what is the marginal? So I'm thinking about I'm saving, but not by not abating. And this is kind of just kind of make our life easier to think about it and to analyze it. It's just the negative of that. It's literally the negative of that. The saving is the amount that is the same as this is what I'm saying. To me, I have to think about it because it depends on which direction you're going. Because marginal abatement actually goes in terms of abatement. This is why I think I suspect all studies and we have a mission. So actually, there is no way I can write something. Actually, I can show you. Because if we had abatement rather than emission, it would be like that rather than like that. Abatement is the opposite of emission, right? So basically what I'm saying is that if you abate more, it's more expensive to you. Right? But here, we don't have abatement on this axis, right? We have quantity of emission, which is the opposite of abatement. So actually, when we think about marginal abatement cost, it's going from this from here to here. This is why they use marginal saving in the book rather than marginal abatement cost, I suspect. To me, I just find it easier to talk about marginal abatement costs, but this is where it's coming from.
Thank you. And about this sentence, the efficient level of emission reduction is achieved at this point.
Yeah.
You mean like at this at this point
Yeah.
it is the
No, at this point in here, at this point in here, how we achieved it, we achieved it through these two firms, right? With the firm 2 does this green bit, exactly what it did. So this is how much they abated. And this is firm 1, this is how much they abated. Together, this is this triangle here. And this is, and this is least cost because, as I show you with the math later on, it showed that their marginal abatement cost is the same. And this is what we need for least cost. This is basically what I just showed you here. Right? So if you rearrange that, so basically what we did, right? Let's kind of repeat that. We had a cost minimization. And we said, okay, generally, what do we need in order to get cost minimization? So when we differentiate that, we got this expression here. This is the marginal cost. So if you move that to the other side, right? Or that's essentially, that's the negative of the marginal savings. So you move to the other side, you get this, and you get that this is equal to lambda, right? And that's basically, that's true to everyone. There is no I here. So that's, if that's equal to the tax, if you set it equal to the tax, it means that, this is essentially the cost minimization solution, because we just showed that for cost minimization, you need that the marginal saving going to be the same across all firms. And this is what we show here. The marginal abatement cost for firm 1 at this point here is equal to the tax rate, and the marginal abatement cost for firm 2 at this point here is equal to the tax rate. So we get cost minimization.
I see.
The marginal abatement costs change along the curve, but at this specific point, the marginal abatement cost is equal for everyone.
Like this stuff?
Yeah.
I've done the graduate bit.
I don't know who was first.
Not me.
I just have a quick question.
Of course.
This is just about like the course in general.
Oh, okay.
When will we know when the exam is? Just because I'm trying to figure out when I fly
So
back.
someone emailed me that, and then I forwarded it to Ruby. And I don't remember the answer, but she answered. So one, you can email me and I can try to dig it
Okay, I can ask
somewhere,
Ruby
or
too.
you can
She
ask
might
Ruby.
be a Good one to ask.
Without, I want to say somewhere towards the end of November, you will know when the Jan exam is, but I can't
I think it's
guarantee
online
that.
somewhere to end of November and early December. I think
This is when they'll tell us.
This is because the thing is that this is done by the school, and
Yeah.
given that like people still choosing their modules, they need to. It's a complex thing because they can't have a clash, so they need to know where people are and kind of then set the exam in such way. And there are so many different options that you can take.
Yeah.
So it's actually quite an operation.
That makes sense.
So this is why they can't do it like we can't schedule in very much in advance.
Yeah. Okay.
They need to wait until the windows of changing is over, etc.
That's all. Yeah, I'll ask Ruby.
I think.
Yeah.
Since we're using like the marginal willingness to pay
Yeah.
to measure the damage, then there can be like an income effect.
Totally. Totally. And but that's what I'm saying. We're gonna talk about the marginal willingness to pay and all of that when we talk about estimation. Now I just kind of try. Maybe I made the wrong decision in including that. It's just to try to think about how we link what we're doing now later on in the course. But we're gonna talk about income and all of this when we think about evaluation.
One thing because that I think is like stronger, but it can be shown because it's like an extension of the welfare theory. But like basically, if you add the Govian taxes and transfers, then you can reach like any Pareto efficient allocation, pollution and production. So like, because if you just add the communal taxes, you're gonna reach a Pareto efficient allocation, which is like maximizes welfare, something like that. But if you do that, and also, for instance, some transfers to income, you are going to reach a different allocation that's also Pareto efficient. But for instance,
I'm gonna talk about it. I think you're talking about double dividends, and I'm gonna talk about it. This is what you do with the revenue.
yes, because it could be like this money doesn't necessarily have to come from the jar. It could be like different money, but like because you can say like, why? I don't know, because like a common criticism is why, for instance, there's a know, goods for luxury goods for rich people, but rich people have a lot of willingness to pay for these luxury goods, and the poor people do not have a lot of willingness to pay to rebuild the factory. So who can be fair? So we could say, oh, maybe the problem is not in the tax, but the problem is in the distribution. So we could transfer to reduce inequality and then achieve a different equilibrium.
So you're saying that if all the problems come from consumption of the more wealthy individual, then you think that one way to solve it is to, this is why I'm trying to kind of think about what I'm trying to say, is to deal with the distribution of the inequality, maybe. But then you come into, so then what would be your end that everyone is equal? No, I'm not saying. I think that what we're trying to do, my response would be like, what we're trying to do is solving environmental issues. That's what I'm trying to do. You say, I see your point, so like, maybe the environmental issue is created by only wealthy people. But never mind, this is one of the things we're going to talk about. We're going to talk about tax regressivity and tax, we're going to talk about something like that, which is a fair point. This is one of the biggest criticism about that. But you can design it in such a way that it's not going to be necessarily relevant. Or you just need to think about high taxes a bit more. Well, what I'm trying to do here is like just show you kind of the very basic notion. Of course there are exceptions. Mindful of time, yes.
Very quick question.
Yeah.
You mentioned that you put some microeconomics
Yes.
readings. Well, I can't find those.
No. Sorry, go to the main Moodle thing. Yeah, and if you go to the last week bit, week 2. Sorry, I wasn't clear.
Awesome. Thanks so much.
All right. Let me. Great questions, by the way. I love it. Great discussions. People feel very strongly about stuff, which I really like it. It's great. And by the way, sometimes I kind of push back on some points. It's not because I necessarily disagree. I just try to push you a bit, right? To kind of think about it more. There is, I just want to mention that there's no criticism of anything. Or don't read too much into the view of the world by me by doing that. I'm trying to kind of make you think about what we're trying to do here. All right. One thing that I want to mention, this came up in the break. So what I just showed you here, right, with the math section here, is that basically, because what we did, we're trying to think about, okay, what do we need for cost minimization? We just set up like a very simple cost minimization problem, right? And we showed that for cost minimization, we need this condition here that the marginal saving or the negative of the marginal cost going to be equal, or marginal abatement cost is going to be equal to everyone, right? It's going to be equal to lambda, and that if you set it, lambda equal t, then you get it, right? The point here, and this kind of going back to the, because I think there was a bit of confusion around that, and it's totally my fault because I didn't explain. Here you have different marginal abatement costs, right? So I'm not saying that the marginal abatement cost curves going to be the same for all individual. I'm just saying at this specific point along the marginal abatement cost, we're going to have the same marginal abatement cost, if it makes sense. So marginal abatement cost 2 and marginal abatement cost 1 are different, but at T star specifically, the marginal abatement cost along marginal abatement cost 1 is equal to the marginal abatement cost along marginal abatement cost 2, which is the condition that we just showed mathematically is needed for cost minimization. So there are two different things. One is the marginal abatement cost curve, and the other one is the marginal abatement cost at a specific point along the curve, or the line here, right? And again, if that's equal lambda, clearly this is what we get, right? If t star equal lambda, okay? So that's my point. Again, just what I show in math is just kind of to formalize what I just showed you here. So and what I explained to you in words. So basically we did it in 3 different ways, which I love, right? So I explained to you in words, we show it diagrammatically, right? We diagram, and we prove it with math. So I think it's pretty, I think it's pretty convincing so far. So this is all great. You can also do a bit, I think that the next slide that I had in mind is kind of think about it, more realistically. Suppose that the EPA set a tax, but it's pretty much the same as what we did before, so I don't really see the point. I need to get rid of this slide, so ignore that. I'm going to get rid of it and update the slides. It's a bit boring. All right. Yes.
Is this also has some assumptions about the transaction cost?
Oh yeah, totally. We're gonna relax some of these assumptions. Yeah, totally. Yeah. I mean, in terms of transaction cost specifically, what do you have in mind here, actually?
Putting the tax and getting the revenue from the tax.
Yeah, I mean, I guess that's pretty. I mean, set the tax. What, to get the revenue from the tax? In what sense? Oh, enforcement and things like that. Oh yeah. Okay, fine. Yeah. So we can. Right, okay. No, we're gonna have a whole half a lecture on that. Wait. Yes. So yes, we assume it's pretty costless, but. And I'm gonna show you some examples actually how these things can be actually quite cheap if you do it right. But we're gonna talk about enforcement, how you want to minimize, how you want to build it in. So basically, the point is. The way that I try to structure this course is that the first, I guess, 4 or 5 weeks is just the very, very basic stuff with lots of assumptions built in, and then we're going to start relaxing assumptions, including what you just said, right?
So then again, this theory assumes no transaction.
Pretty well. If you define, yeah, I don't have anywhere here that represent the cost of collecting the tax, for example. If that's what you mean, the answer is yes. But it can be pretty cheap. Compared to the overall revenue that you will generate and the benefit that you will capture from that in terms of welfare. Yes. No, that's what I'm saying, and I'm going to show you even now when we talk about dynamic efficiency. There's lots. I mean, I'm not going to even here incorporate the cost of innovation, which is obviously a big cost. But again, what we're going to do, we're just going to look at the basics, and then we're going to try to think about, again, in week, I guess, 5 onwards, about what happened when we relax this assumption. I mean, okay, there is also like time stuff and space and all of these kind of things that really change things, right? So we're gonna cover that, but I'm going to show you how. As I showed you last week as well, how, for example, transaction costs might change things, okay, a bit. So remember in the seminars we talked about, look, if the transaction costs are higher than the potential gain, we might not going to move with the cost theorem. Remember that? So it's kind of the same thing in here. So if the welfare gain that we're going to get are less than the transaction costs, which to be honest, it seemed unlikely in the case of tax. Not necessarily in terms of innovation, what I'm going to talk about now. But it's a fair point. Yes, and I assume lots of stuff, information, yes, all of this stuff. Okay. What did I want to say? Okay, so far we talked about static efficiency. Again, what is static efficiency? We achieve the desired level of pollution at the cheapest way possible. Okay, and I show you that again in 3 different ways. Okay. What is dynamic efficiency? Dynamic efficiency is that we introduce time here, and to see whether whether taxes, right, produce some incentive for firms to innovate. And I think that someone here before mentioned innovation. Okay, and it's a great day to talk about innovation because of the Nobel Prize that was announced today, including our very own colleague Philippe Aguillon that works on this kind of stuff as well. Right, he's a professor here at LSE, got the Nobel Prize with 2 other random people. I'm joking. Okay, so what's going on here? So let's consider that there is not 2 firms, 1 firm. Okay, 1 firm, but they have 2 potential marginal abatement costs curves, right? MAC1 and MAC2. Okay, let's first say that they have MAC1. Okay. And now we decide on a tax, okay? Forget about MAC2 for now, right? We just decide on a tax. We have MAC1 marginal damage. Let's say the government decide to put a tax here, T star, where the marginal damage equal to marginal abatement costs. What's that going to do to the firm? Well, the firm needs to decide how much they want to abate, how much they want to pay the tax. They're going to end up in this point in here. What's going to be their abatement cost? It's going to be A plus B, right? These 2 triangles. But that's not all they need to pay. Don't forget, polluter pay twice, right? They're also going to have to pay the tax, which is 0 to E1 times the tax rate. So it's E, C, and D. So overall, they're going to have to pay A, B, C, D, and E. That's quite a lot. The question, whether now they have an incentive to innovate. So let's say, is it better for them to move from MAC 1 to MAC 2? The answer is yes, right? Let's look at that. What happened when they move here? Well, two options, right? Let's say that the government doesn't react to this new innovation, which is a very likely situation, at least in the medium term. So what's going to happen? Well, they again need to decide how much they want to abate. Where are they going to end up? They're going to end up actually here, right? At E2, right? Because it's cheaper for them to abate, cheaper to abate, cheaper to abate, even after this point in here. Cheaper to abate, cheaper to abate, cheaper to abate. Okay, they're going to go all the way up here. Right? What's going to be their abatement cost? The abatement cost is going to be B plus C. Okay? How much they're going to have to pay in terms of tax revenue? They're going to have to pay E. Right? It's this distance here, time T star. So are they better off compared to the being with MAC1? Yes, right? They need to pay less. How much? Well, these areas here, right? A and D, essentially, assuming that D is this whole thing here. Right? Before they pay all of the shaded area, either through abatement costs or tax revenue, now they pay less. Even though they're doing more abating. Yes? Over abating, you mean? Over abating. Yes. Where it's no longer welfare, like per acre. Yeah, I mean, they're over abating because this very simple example, the government did not update their analysis in terms of what should be the new tax, right? Because we set up the goal given the old marginal abatement cost, right, which is this guy here, but actually if you were to set it up or update it, you're going to be here. In fact, if you do that, is that good? Is that good for the firm? Does that give it even more incentive to innovation? Yes.
If the government actually, does the taxes, reduces the taxes when that happens, yeah, it definitely is better.
Exactly. So if the government updates, it's even more incentive for firm to innovate because now the tax, exactly as you said, the tax was here, right? At this point in here, now the tax is going to be here at, T star prime, which is lower. So obviously they're going to pay less. You can kind of try to draw the diagram yourself at home if you want, but it's definitely worth it for the government, for the firm. So the point here is that tax is fantastic. I told you I'm going to be very enthusiastic about it. You get the desired level of pollution, you get the least cost, and you provide firms incentive for innovation, which I would not underestimate the importance of that. You basically incentivize them to create better technology, cheaper ways to reduce pollution. Yes?
I was just wondering what happens if you introduce uncertainty.
Oh yeah, we're gonna talk about that. There is a whole we're gonna talk about uncertainty. Yes. No, so two things. First of all, going back to your points before and kind of, I think following on this one, what we don't have, this is like a very simple stuff. And again, we're going to relax on the stuff. You're talking about natural resources, going to talk more about it because that makes things a bit more complicated. You need to think about exactly when you want to extract, kind of the optimal extraction, and kind of when you want to sell, all these kind of different things, which require a lot of, a lot of work, which we're going to do. Well, when I say we, I mean you guys with Frank. But in terms of this thing here, which is something that we don't, as I mentioned before, we don't even show, what's the cost of moving from MAC1 to MAC2? It is not representative. fact, you can think about, okay, going back, I guess, to your point before, if the cost of innovating is more than A plus D, there is no incentive to innovate, in a way, or they're not going to innovate. So you also want to think about, and you're going to have, I think the last 3 lectures of the next term will talk more about innovation and stuff like that. But you need to think about why, for example, you might want to subsidize innovation. I'm going to say how subsidies are bad, but maybe in this case it might work. It's a very complicated course. We're going to contradict ourselves a bit, but we don't actually. It's just you need to think about what you want to do when and where. Okay, but that's kind of one of the points actually. Which I don't know if I answer your question exactly, but there is some things here that do not, and your uncertainty point as well, are just not capturing this very, very simple explanation of how the tax system work. Yes? So first of all, this is just like a very simple way to think about taxation. I'm not going to propose different, all these kind of different tweaks about how you want to set up your tax system exactly. But given what you said, you need to be, I don't want to get too much into that, but you can, this is just one way to think about taxation. But once we start, I mean, you can do a whole course about taxation, which I don't want to do. Because even for me that like taxes, I don't think it's that interesting for a whole year to study about taxation. But yeah, I just don't want to go too much into that, but that can cause some other problems. And we can talk about it offline, right, if you want. Okay, so basically what I'm trying to say, big picture here, okay, without all the small details. Which I'm saying that like half joking, but it's actually important because you get the gist of it, and then yeah, there are some things that we can maybe tweak, but the point is that on average or overall, taxes provide firms incentive. It's not because necessarily they care about for innovation. It's not because necessarily they care about abatement. It's just because they're trying not to pay tax. That's the point. They're just trying to avoid paying tax. But when we do that they avoid paying tax in a way that we really like as a government, by innovating and creating. I mean, look, by innovating, the other interesting stuff that happened is that actually if they update, now the efficient level of pollution is lower. So that's actually good for everyone as well. It's not just for, so that's kind of a great stuff that happened, okay, with this innovation. This is why the dynamic thing is potentially even more important than that. Okay, so far I showed you, again, static efficiency, desired level of pollution at the least cost, plus incentive for innovation. That's amazing. Can tax be any better than that even? Like provide more, great stuff? The answer, according to some people, yes. And this is kind of what we call the double dividend hypothesis. And people were talking before about what we do with the tax revenue that we collected. So the double dividend hypothesis arises from the possibility that the revenue from an environmental tax could be allocated to mitigate the distortionary effect of other taxes in the economy. So as you know from your undergraduate courses of micro or public or whatever, that every tax creates some distortion, right? So for example, income tax creates distortion between how much you want to allocate to leisure versus work, right? So all these kind of different things. So the point here is that the environmental tax has 2 benefits. 1, improvement in the environment in the cheapest way possible, and then efficiency gain from the economy as a whole, because we can use the revenue that we got from the tax, right, the green tax, the Pigovian fee, whatever you want to call that, and then reduce, for example, income tax. That's the point, okay? And this is why sometimes, people call it a no-regret policy, a win-win solution, but to be honest, there is a lot of debate around that. And and there is a cycle every 5 or 10 years, I don't know. It comes back about the double dividend and discussions around that and whether that's true or not true, whatever. There is a whole section. I'm not going to go too much into that. I can provide you some kind of, if you want, you can email me. I can give you some ideas about what you want to read. If you're interested in this debate, it's been ongoing. And I'll tell you what I think about it. So one option is that, okay, you can generate everything that you need from this from these tax, all the revenue that you need, right? And that might be the case. Okay, so then you don't need other distortionary taxes. But if there is a more realistic kind of situation that you can't generate it completely, basically you're going to use some of it in order to reduce other taxes. To me, I don't know, but again, that's something that are being continued to be discussed. But basically, to me, it doesn't really make sense because if that's the case, it means that your original tax system wasn't efficient. Basically, if you were in a Ramsey optimal taxation situation, it just means that you try to raise a certain revenue from taxes, and you do it in the most efficient way. Why didn't do it to begin with if that's less distortionary than other taxes? Right? Because if your whole point is just to raise revenue to fund services or whatever, then why did you use income tax, for example? That is, I'm not saying that it is or not, but that is more distortionary. Again, there is a lot of debate. It's every 5 years someone comes with a new paper, argue the opposite or whatever. I saw someone, I think last 2 years ago, coming here presenting some new results on that. But to this specific criticism, they didn't have a good answer, right? Why the government just didn't go ahead with raising by this way? They decided to go with something else that is income. Why that's the case? So fundamentally, I'm not necessarily see the point, but totally, if that's kind of what helped to sell taxes, I'll go with that. Yes.
You're saying that, like, why didn't we do it in the beginning? Many of those taxes were set up in 2010 already, and like we only, for instance, if we take climate change, already knew about it.
Yeah. Okay. So as soon as you know about why don't you? But then don't say that it's kind of like you reduce it just by that. Just like you set up the taxes every year. You have the budget, whatever. You just set it up. Why didn't do it before?
I mean, that's a part.
So it's just an information. That's what he's saying. So we didn't have this information before. Now we have this information. Yeah. So that's fair. Yes.
Yeah, another way of saying the same thing is basically we are talking about like having violet dividends because that requires like starting from a previous situation which was suboptimal. But to say that simply for most taxes, there's a trade-off like, oh, we need money for like providing public goods, but that's gonna generate a cost inefficiency in the economy.
Yeah.
But like Gregorian taxes are like, oh, it's gonna increase the efficiency in the economy and it's gonna create revenue for public goods. So.
No, but it's also distortive. So the point is that it depends what is more distortive.
But it doesn't really.
It does distort because when you introduce that, of course, you affect people's decisions. So it does create distortion.
But you do it to counteract market failures.
But this is just from the environmental perspective, but it still create distortion. Any tax that you put forward will create distortion. But this is why there are two different things. Look, I'm in favor of taxes, right? We're on the same side. But I'm just saying that there's two different things. One is the improvement in environment, totally in favor. The other point is that, which is great. This is why, just on the basis of that, I think we should do that because of the market failure. The second thing, whether that gives this kind of double dividend in the sense that it just replaces a more distortionary tax. That was my point on the second bit in here. Okay. So again, if all of it can be, or if all revenue can be generated from the green tax, that's okay. But if not, then I don't see why we just didn't do more of that before or something like that. That was my point. But again, it's still debatable. You can make your own decision. All right. An important thing that we haven't talked about, so far I just said everything is great, but taxes may be regressive, and I think that we talked about it a bit before. What do I mean by that? Households with lower income pay a greater share of their resources than those with higher income or wealth, depends on how you want to see that. And this is a key argument in the debate about the use of carbon taxes, for example, to deal with CO2 emission. especially direct household CO2 taxes. Okay, so let's examine a concrete example here to kind of show you just kind of an example of what do I mean by that. So in an effort to fulfill a rather ambitious actually national reduction targets of CO2 greenhouse gases emission in where was that in Denmark. The government decided to put a tax on CO2, both houses and and business energy consumption in the early 1990s. Okay, so there are two parts of it: direct CO2 tax payment on energy consumption, and indirect tax payment on commodities such as water, travel, various type of food. And let me kind of show you what happened, and we talk about whether it's regressive or progressive. So what you see here, this is from a paper that was published in Ecological Economics quite a while ago in 2005, examining the consequences of this tax. So first thing that you have here, this is just the number in terms of euros about how much they actually pay across different decile of the income distribution. And if you just look at these squares here, it looks like, right, just looking at these guys here, how much they actually pay in terms of actual payment. This is actually quite progressive, right, in the sense that richer households, I mean, it's income, but you know what I mean, households with higher income pay, on average, right, higher taxes, right, in terms of actual payment. So that looks actually going in the other direction. But this is not the full picture, because what you actually or potentially want to look at is how much of that, or what's the share of disposable income that they actually spend on this stuff. And this is where the bars here kind of, this is what the bars here shows you. So again, this guy here, these dash bars, I guess that's the direct tax in terms of the share of disposable income. And the more solid one, I guess, is the indirect tax. And it's a complete opposite picture, right? So basically what it shows that in terms of disposable income, which I think is what, in my view, matter quite a lot, if I think much more personally, it's very aggressive. So basically it means that in terms of disposable income, households with very low income paid much more than households with high income. So, and that's something that you really need to remember. Okay, who pays that? But it's not just who pay and how much, it's how much of the payment is of the disposable income that they have. Because, yeah, maybe they pay more, but it doesn't really affect them that much. So who are the people going to be most affected by that? I would argue is these people here. And if you don't take these things into consideration, it can really backfire. Politically, but also morally, I guess. But even if you don't have any moral, that's okay here as well. I mean, I hope that you do have something, right? Otherwise, you wouldn't take this course. I would hope, I don't know. But let's keep an open mind. You don't have morals. It can backfire. If you just care about, the environment, whatever, you don't care about, how you affect people in your society in any other way, then it can also backfire, because that might be something that's going to be very, very damaging politically, and that can lead to a U-turn. And this is kind of going back to my next slide, which, by the way, I had lots of conversation whether that was the cause of that or not. And I'm not saying that if there are any French people in the crowd, which I think there are, whether that's kind of the cause of the yellow vest movement. I'm definitely not saying this is the cause, but I just found this kind of article in The Guardian that's kind of interesting. And this is what it says here. The majority of the hundreds of thousands of the yellow vest protesters are from low or middle income families who are hardest hit by the fuel price rise because they spend a disproportional share of their income on fuel and transport. Basically, if you don't remember what it is, because it was a few years ago, basically there was a tax, and if someone can correct me if I'm saying something wrong, there is kind of a policy by Macron to increase certain fuel prices, and that led to, well, I don't know if that was the whole story, but part of it, or that was the excuse or whatever, led to massive protests that essentially at the end led to a U-turn on this whole policy. And according to The Guardian, at least. One of the reasons is that as well. But it's just to kind of make the point that you really need to think about that. Even if you, again, which you should, but let's say if you don't, just from kind of the success for the policy, you need to think about this stuff. Yeah.
But that issue would happen with any tax unless the tax is directly linked to income, no? Any other tax would have the same issue.
No, so you need to think, well, I mean, and then this is kind of going back to your point that you made before, is how you design the tax quite, you can design, for example, it's income dependent. You can decide on what exactly you want to tax and how you want to tax from a certain, you suggested from a certain level or whatever. You need to design it, you need to think about that as well.
But from this issue, the only solution is that all to not have the issue that always have to be linked to income. The other variables doesn't really matter for the regression.
No, but, well, yeah, but the point is that you can deal with this stuff. For example, let's say that, okay, I don't suggest that this is the case, right? But there are endless solutions. But if this is the case, let's say you put a tax on diesel or whatever. Who uses the diesel? So you need to think about that, all right? So are they kind of people that are more in this kind of brackets or this far? If not, maybe you want to tax another type of fuel, one example. Or you can provide them with some help, for example, to change their fleet or something like that. But it's really endless, the possibilities. You just need to think about it. What I did before, when I show you all the diagram, I just did it in the most kind of simplest and intuitive way, but you can need to think about all this stuff a bit more.
But then at the end, you will have the same issue because the people have less money.
Okay, so let me give you an example, right? So let's say that I tax diesel, for example, and you have a diesel car, and most of the people that have diesel car are in the low. I'm gonna give like an unrealistic, well, semi-unrealistic. And I said, look, you know what? I'm going to tax diesel, but for example, I also at the same time provide you a strong incentive in terms of like maybe cash transfer even to change your car to a non-diesel car, and I'm going to give you money towards that, which is not actually necessarily something that is not happening right now in other parts of the world. Okay, so I can do two things at the same time. And then you don't necessarily need to stay with it.
Yeah, exactly. My point was that the issue is not the tax itself. Like the problem of the tax here was not the issue that
No, the point was that who is actually going to be affected by the tax? That was my point. If you don't do anything else, which seems like what they do, actually in many cases this is what happens. But in other cases, what happened? I mean. In some states in the U.S., I mean, look, there is massive variation in gas prices in the U.S. across states, right? If you go to California, I mean, when I was there last year, I think that you pay, well, depends on which station you go, but anywhere between $4.60 to $5.20 per gallon. When I was you were talking Dallas in Texas, it was around $2.20, right? That's a massive difference. Now, the thing about California, you see lots of Teslas that people don't really use because they have like an amazing, well, they give so much incentive to get electric cars. We're going to talk about that as well if you want. But basically, they also provide you some opportunity to move away from this kind of, from paying this tax. So it actually, like, lots of people say, like, it doesn't really make sense not to get a Tesla. Or, sorry, I don't want to buy a Tesla or electric car in California. It just kind of makes sense. Yeah. Because of the way. So you kind of, that's what I'm saying. You couple different policies together to kind of get around that stuff. Yeah.
If I understand the graph correctly, what it's saying is that like the wealthiest people are paying more absolute tax, but less percentage of the disposable income.
That's exactly what you're.
So basically, if you took like if you took all the revenue and distributed it equally to all these deciles, then you would have that actually that combined with it progressive, you would have like the poorest to actually gain net transfer rather than like if you give everyone an income.
I see that you're very keen to use the taxes. I need to think about it. Right? I just want to progress a bit. Yes.
I have a question of how do you create a tax in this context? So, for example, let's say in Colombia, they want to take this as
so it's all connected. This kind of, I think that's one of the point here. There is the indirect and direct tax. So yeah, so one of the, yeah, so what you say is just the fuel itself, but then the other thing is like, well, if you want to transport food, for example, that's also be affected by the changes, well, in the taxes because it's going to make food more expensive. Again, is that right? Or
Yeah, so
because this is how you transport food
you
into
were
it.
giving like some examples of how you could manage that.
Yeah.
So in that scenario, how would you
I mean, look, I don't know I just give like a crazy example or semi-crazy example. I think that it's going to be very, you know, I need to know much more, and I think there are better people that can design a tax system than I. That can advise you specifically on this specific case. But we can talk about some crazy options if you want during my office hours. But I really need to move on. So quick question, and then I.
I wanted to say something on that. Maybe like if you talk about how to make all of these politically feasible, there's like a whole strand of literature called like just condition political science, not economics, that like looks at how to get people on board because like people always oppose changes to taxes like or subsidies when they're worse off. And I think that's like less an economics question and more a question of political science to look at how to manage this.
I mean, yeah, I mean, there is definitely these two things. So one is like how we can, you know, make people kind of on board the policy, which is kind of your, I think your point, right? So kind of, yeah. So that's definitely there is a whole literature on that. But also in your point about if you're gonna really care about, you know, the effect of the tax on the distribution, there are things that you can do to deal with it. But for that, you need a lot of information, and that's actually increased transaction in this situation because you need to know. But again, I've never been there. I don't know what's going on. I don't know. So you need a. It's actually a great point. Is to make it. It's actually a great point that you raised because different situations require different solutions, right? So the way that you design the tax for one place not necessarily going to be the same as in another place because it's just the circumstances are different. The way that we do that, you know, the income distribution, how you move things, goods, etc., across, and what's going to be affected. I really have to go. I like all your comments, but we have 10 minutes. I need to talk about subsidies and command and control, which is quite a lot in 10 minutes. But let me try. All right. All right, so on the course, we showed that efficiency is unaffected by who hold the property rights. So in the case of Pigovian fee, we might want to ask ourselves whether subsidies are as efficient as taxes, because what is a subsidy is just a negative of a tax, okay? And whether there is any danger with subsidies, and more generally, can efficiency be achieved? So let's kind of talk about it. The way that we're gonna think about it is one, we kind of already established, and we're gonna reestablish again in just a second. The tax is efficient, it's great. And then we're going to see whether subsidy reaches the same level of efficiency. And we're going to consider that in actually 3 cases, but broadly speaking 2 cases. What do I mean by that? We're going to talk about short run and long run. But within the short run, we're going to look at the case where all firms are the same, and one case when we have heterogeneous firms, so different types of firms. Right. Short run, let's start with the first one. Assume that all firms are identical. So this is kind of the first point that I try to make here. Short run, no time for entry, and all firms are the same. So the first bit, all firms are identical, no new entries. Under a pollution tax, the cost function going to be given by this CT here, which depends on Y and E. So Y is goods, E is emission, V is the variable cost of function, and FC is the fixed cost. Now we can assume that E is related to Y with this factor A. So this is how the production causes emission through this A here, this factor here. The cost function can be rewritten. What I have here, so this is the variable cost, the tax, and the fixed cost, and we can replace all the E's with a Y. Okay, this is basically what I said here. So I can rewrite that like that, and then I can again rewrite it like that. Okay, so what's going on here? It means that if I just differentiate this guy in here, what do we get? We get that the marginal production costs are given by this guy here. Okay. So what is that actually says here? This is the marginal cost. So if you can move to the other side, it's the marginal saving equal to AT. So the effect of a pollution tax is to increase MT by MC, the marginal cost, by this amount, AT, okay? Which is basically what we showed before, okay? Now let's consider a subsidy, okay, instead of a tax. With no attention to pollution control, the firm will emit EH, right? So they're going to be at a private optimum. The subsidy payment will be S, the subsidy rate, time EH minus E, so how much they actually cut their pollution, or emission rather, okay? So this is here to move from this EH to E. EH is the efficient level, the privately efficient level, okay? So how we can adjust our cost function now, so we're going to get this cost function, which is the variable cost, the fixed cost. Now, remember that before we tax, we had a plus before, right? We have to pay more. Now we get a subsidy, so the cost is actually being reduced. So it's going to go with a negative sign here. So it's a subsidy rate time how much we actually cut our emission by. And we can rewrite it, given everything that I showed you in the previous slide, like that. Okay? So what do we get out of that here? The term in brackets is the fixed cost plus lump sum transfer that is independent of the firm's choice of Y. So that doesn't, we don't really care about that. So what do we get? We get essentially the same thing that we got before. We got that the marginal saving equal to SA. So if S is equal to T, right, or if the subsidy rate equal to the tax rate, we're going to get exactly the same thing. Okay? So our first result is that in the short run, when we have identical firms, subsidies and taxes yield exactly the same outcome. Okay, because we already proved before today that taxes are efficient, and now I'll just show you that subsidy is going to get exactly the same thing as when we have taxes. But again, crucially, this is when it's only the short run and all the firms are the same. Now let's consider still in the short run, but now there are heterogeneous firms. So there are two types of firms, right? And old and new firms. New firms have higher fixed costs but lower variable cost, right? Which kind of makes sense. No new firms can enter, again, short run, but old one can close, normal stuff. Subsidies is paid only if the firm remain in business. And as you know, in the short run, we don't care about total costs. We only need to worry about whether the price is higher than the average variable cost. As long as this condition hold, then production occurs and we get P equal MC, okay? P equal the marginal cost. So what do we have here in this diagram? I think it's easier to explain what's going on here. With this diagram. So we have new firms on the right-hand side and old firms on the left-hand side. You get the average variable cost along different kind of regime. This is when we have tax. This is when we have unregulated environment. This is when we have subsidies. Remember, with the tax, the average variable cost goes up, right? And with subsidies, it goes down. And here we have the prices under the three different situations. This is coming from another figure, actually, that I don't have here, but it's in your Costa textbook. And what do we see with the new firms? It's look, if you have a tax, the price, right, actually of the good, is higher than the average variable cost for actually all of them. So they're going to continue to operate. It's all fine. The same thing go with subsidy and with the unregulated situation. Okay, so that's all fine. Now let's look at what happened with the old firm, because this is where the interesting thing actually happened. Look, if we have, if we have a subsidy, right? It means that the price actually going to be higher than the average variable cost when we have a subsidy. So old firm will remain and continue to produce. If we have a tax, that's not the case, because the price is actually lower than the average variable cost. So, and we know the tax is efficient. We know that, we established that. So basically what I'm saying is that if we subsidize, we might incentivize firm to stay in business, in this case in here, for example, where they should not be in business. Because with the taxes, these firms will be out, even in the short run. Because the price, right, is lower than the average variable cost. So they're going to shut down. But by providing subsidies, we actually incentivize them to stay. We subsidize, essentially what we do, we subsidize inefficient firms. So this is why subsidies are not necessarily great. And I haven't even talked about going back on all this kind of tax revenue, whatever. How on earth are we going to get the money to subsidize? We need to increase taxes somewhere else. They are distortionary. What's going on, right? I'm not even talking about that. But going back to your political point, So politics, or as we like to call politics in economics, political economy. Don't know. But I think it's kind of the same thing. It's not exactly, but it's similar. But this is one of the reasons, by the way, why it's easier to sell a tax, right? Because you don't need to raise taxes. I mean, you don't tax someone directly, but then people don't really necessarily see that, oh, but where do we get the money for the subsidy? It's coming from somewhere, but it's less visible. So that's kind of, I guess, something that worth thinking about. But this is potentially why it's easier, because it's just, the cost is more hidden, I guess, when it comes to subsidy. Of course, the subsidy comes from somewhere, right? Okay. The last bit that I want to show you is what about the long run. So in the, let's go here. Okay. Right. So in both short and long run, a tax raises the marginal cost and average cost, and a subsidy raises marginal cost but lower average cost. And as I said before, in the short run, firms operate where P equal MC. Right. If we assume a constant cost industry, all firms operate off the bottom of their average total cost curve in the long run equilibrium. So the supply schedule for the industry will be horizontal. If this is the case, it's just going to be at the bottom of the curve. The result is that good prices will be higher with the Pigovian than with a subsidy. Furthermore, taxes will be more. There will be more firms under a subsidy than under a Pigovian fee. The basic point is that a subsidy increases output. So basically, what happened, I can show you that here, is that, all right, look at that. So basically, what we're going to get a supply schedule from these figures here, right? This is the bottom of this average total cost, right? So this is what we have here. This is with tax. This is with unregulated. This is with subsidy. When we unregulated environment, this is the output that we'll produce, okay? And you can link that with emission. When we have tax, we're going to get what we wanted. We're going to get, we're going to cut some of this emission. Go back here, moving from E-private to E-efficient, ideally. If we provide subsidy in the long run, we're actually potentially going to end up in a point like here that there is actually more production. Why is that? Because when we provide a subsidy, it's related to this point that I made here actually. Because we essentially going to subsidize inefficient firms, but more than that, over time, we actually provide incentive for inefficient firms to enter the market because of the subsidy. So some firms might enter the market because of the subsidy. And this is why it's something that it can be very problematic. All right. We have 2 minutes for command and control. Should we just do it next week? Do you want to go home? We did a lot of stuff today. What do you say? Who want to go home? Raise your hand. Don't be shy. How quick can I do that? No, let's do it properly. Let's start with it next week. I don't want to rush it. I liked all your questions and all your comments in the discussion. I prefer to, delay 1 or 2 things for next week. I'll see you on Wednesday. Thank you. Yeah, I'm right with you. Yes. Yeah. Yeah, this is why I never use that. But I just ignore that. This is just a negative. That is just so much easier. There is a whole 2 paragraphs in the book about that, but I just find it so unclear. Yeah, it just because I just really I think yeah. You all right? How are you?
I'm very aware that in this course I need to read up on all my
It's like a vocabulary clause.